Boom! Alright folks, you me again. How are you going? In this video, I want to treat with a topic that I've seen be of interest and concern to a lot of students, and that is the topic of addition and subtraction of fractions. Now, we know what a fraction looks like. Alright? We have the numerator and we have the denominator. So we say 3 over 7. 3 is the numerator, 7 is the denominator. Let us say for the sake of argument that we have 7 over 3. 7 is the numerator, 3 is the denominator. This here is what we refer to as a proper fraction. Right? And this here is what we refer to as an improper fraction. Right? Yeah? The improper fraction we know is the one where the numerator is larger than the denominator. The proper fraction is the one that we are comfortable with, the one that we're more familiar with, the one where the numerator is less than the denominator. Now, in general speech, from time to time you'll hear people talking about reducing something to the common denominators. It doesn't have to be anything pertaining to maths, but it is a phrase that we use in general speech. You would hear people talking about the common denominator between two particular issues or between 3 or 4 particular situations. The common denominator between so and so over here and so over there is A, B, C, X, Y, Z, blah, blah, blah going down the road. So, think about that in terms of the English language, and I am sure that there is the appropriate equivalent in other languages. The idea is the same back in the maths when you're adding and when you're subtracting. Because the fundamental principle when you're adding or subtracting two fractions, and we will restrict the discussion to 2 for now, because the interaction between two fractions is the foundation for everything else. If you're adding 3 fractions, you had to know how to add 2 first, right? So, the fundamental, the core principle, the foundation of addition and subtraction of fractions is this. We have to get the fractions in the same denominator. Once we get that, we don't have a problem. Matter fixed, as we say here in TNT. Right? So let us start the discussion by talking about the situation where we have fractions where the denominators are the same. Simple example. Let me use the same 3 over 7 that we have here. Alright? So if I have 3 over 7 and I say 3 over 7 plus 2 over 7, even if you didn't do a set of fancy maths in school, you look at this and something tells you that 3 over 7 plus 2 over 7 could only be 5 over 7. If you have 7 over 3 and you have to add that to 9 over 3, again, something about that just tells you that 7 over 3 plus, let me not use 9, let me use 11. Because 9 is a multiple of 3 and 9 over 3 is 3. 7 over 3 plus 11 over 3, something about that tells you that 11 plus 7 is 18 over 3, which is equal to 6, but that is a separate conversation. We're not dealing with that here. Right? So, that's it. Anytime you have 2 fractions to add, if those fractions are already in the same denominator, then you just add the numerators. And as we're talking about English and all that, think about the word denomination. Whether you're applying it to currency or whether you're applying it to religion, right? The whole idea of a denomination is about something being common. Alright? So in other words, we could say that we have the 3 and the 2 in the same denomination because the denominators are the same. Right? We just Englishifying the maths a little bit. right? We could say that we have the 7 and the 11 in the same denomination because the denominators are the same. So anytime you have two fractions to add and the denominators are the same, in other words, the fractions are given in the same denomination, then you just add the numerators and the problem solved. Now the logic is the same for subtraction. So let me change the addition here to subtraction. If we had to say 3 over 7 minus 2 over 7 this time, 3 over 7 minus 2 over 7, again, you look at that and something just tells you that the answer is 1 over 7, and it will be quite correct. Because 3 over 7 minus 2 over 7 is in fact 1 over 7. Same story over here. You have 7 over 3 and you have 11 over 3. 7 over 3 minus 11 over 3, you have subtract that, and what you get? 7 minus 11 is minus 4 over 3. Alright? So, just as was the case when you were adding, when you're subtracting, you want to get the fractions in the same denomination, which is the same denominators. And when you do that, you just subtract the numerators. So having the denominators equal means that you could then carry out the arithmetic at the level of the numerator. Alright? Now, I want to take a couple of minutes here to just show something that a lot of people don't understand. Because 3 over 7 plus 2 over 7 is the same thing as 5 over 7. What this actually means is that 3 over 7 plus 2 over 7 is the same as 3 plus 2 over 7, which is equal to 5 over 7. This is a very important skill in maths. You had to be able to see that 3 over 7 plus 2 over 7 is actually 3 plus 2 over 7. So in other words, because the denominators are the same, as we discussed a few moments ago, we have a common denominator here. In other words, the 3 and the 2 are in the same denomination, and with that in place, we just add it on top and get a 5. Same thing if we were subtracting. 3 over 7 minus 2 over 7 is the same thing as 3 minus 2 in the numerator all over 7, which will give you 1 over 7. Right? That's basically it. Now, the reverse is also true. Because, hold on. Because if you start out, let me flip the script now. Right? If you start out with 3 plus 2 over 7, you have to be able to do the reverse and say that if 3 plus 2 over 7 is the fraction that we have, then this is the same thing as 3 over 7 plus 2 over 7. And by the same token, if you start off with 3 minus 2 over 7, you had to be able to recognize that that is the same thing as 3 over 7 minus 2 over 7. Alright? So, one coin, two sides. One of the fundamental principles in maths and with a lot of things in life is that every coin has two sides, right? And you had to be able to see the both sides of the coin to be able to connect certain things together. So we're going to repeat the same idea now with the two fractions at the bottom. So you have 7 over 3 minus 11 over 3, and again, because the denominators are the same, because the denominators are common. In other words, the 7 and the 11 exist in the same denominations. Then we could say that 7 over 3 minus 11 over 3 is the same thing as 7 minus 11 all over 3, which will give you a minus 4 over 3. And by the same token, if we were adding, we would say that 7 over 3 plus 11 over 3, right, is the same thing as 7 plus 11 over 3, which in this case is 18 over 3. Same difference, right? And of course, just as we did a few moments ago, if you started off by saying, 7 minus 11 over 3. If you started off with the fraction written like this, then because everything here has the same denominator, you could write this as 7 over 3 minus 11 over 3. And by the same token, well, of course, which will give you the minus 4 over 3. And by the same token, if you were adding, if it was 7 plus 11 over 3, then you do the same thing. You say 7 over 3 plus 11 over 3, and you get the 18 over 3. So in other words, the simplest addition and subtraction that you will ever do in your life is the case where the denominators are already common. Now, of course, examinations being what they are, you would hardly ever get two fractions added with the same denominator. There would be almost no point to that. That is how simple it is to understand and to execute. You also, by the same token with subtraction, you may get two fractions to subtract with the same denominator because the issue of the negative sign complicates matters, right? 7 minus 11, that is a whole scene for a lot of people. The minus sign is a whole issue by itself. But in general, when you're being tested on the addition and subtraction of fractions, the usual situation is that the denominators are different. And it means, therefore, that you have to do something. You, as the person executing the addition or the subtraction, now have to make an intervention. You have to do something mathematically to make the denominators common. And that is the heart and the soul and the core and the foundation of adding and subtracting by fractions. So the easiest level, let me say level 1, is the level where the two denominators are the same. If that is not the case, as it usually will be, it usually wouldn't be the case. That's what I'm trying to say here. If it is not the case that the denominators are the same, then you have to do something to make it the same. And yes, I know I just repeated myself somewhere within the last 2 to 3 minutes, but that's okay. Repetition is part of the game too. So the next video to follow this one would be where we start to discuss the situations where the denominators are not the same.